All right, good evening, everybody. And today I will be discussing to you part two of chapter three. I do apologize from last video because I did skip this part, this part specifically, because I really got tired, guys. Yeah, it's just a human thing, no. So let's just, without further ado, let's just get in right into it, no. So let's talk about interquartile and semi-interquartile range. But before that, let's talk about what quartiles are. From the word quartile, it means quarter. And we know that a quarter of something is 25% of it. And that's basically it. It's 25% of it, right? So if we are to kanang a distribution of test scores, right? A distribution of test scores can be divided into four parts, and these parts are called quartiles, such that 25 of the test scores occur in each quarter. So there's actually four quartiles, guys. There's Q. I know there's actually three quartiles, guys. There's Q1, Q2, and Q3, and we have four quarters. Now, quartiles, guys. Quartile refers to a specific point, whereas quarter refers to an interval. So let's see over here, no? You can see that these points indicate quartiles, while these intervals, these spaces you see in between, are called quarters, right? Okay. Now, it's important to note that Q2 is actually the median, right? Q2 is actually the median of 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 the distribution. So like Q2 and median are basically the same, right? And Q1 and Q3 are called the quarter points, right? So you have Q2 as the median and Q1 and Q3 as the quarter points. Now, formulas may be employed to determine the exact value of these points, but actually, guys, unfortunately, the book doesn't give us the formulas to be, to be used to really indicate the specific quartile, no? Now, how do you word this out? You can say na like an individual may, for example, fall at the third quartile or in the third quarter. So when you say fall at, it means it falls in that quartile. Like it's since it says third quartile, he falls at here. He falls at here. But when you say in the third quarter, then therefore he's here, right? What happens if you say an individual falls at the third quartile but is in the fourth quarter? Therefore, you go here. Gets ba? I don't know if I'm going too fast, guys, but that's the least I can say. Also, it's worth noting that the reason why 25% shy is because once you add all of this 25 plus 25 plus 25 plus 25 on each quarter, it becomes 100%. Therefore, 100% of distribution points or scores. Now, what do we call the interquartile range? The word interquartile range, this is the range wherein you get from the quartiles, specifically quarter 1 and Q3. Now, to be more frank, no, the interquartile range is a measure of variability equal to the difference between Q3 and Q1. So all you have to do, guys, over here, no, let's look over here. All you have to do to get the interquartile range, all you have to do is you minus Q3 minus Q1, and that's pretty much it. That's pretty much it. Now, for semi-interquartile range, this gets easier. You know why? Because once you get the interquartile range, right, you get the answer, like let's say 0.92. For example, yeah, 0.92. Hold on, that doesn't look like a 9, that looks like a G. There we go. That you get 0.92, right? All you have to do is divide it by 2. And that is your semi-interquartile range. That's pretty much it. Very easy, no? Now, let me just erase this, shall we? Okay. Now, so yeah, I think that's pretty much it, no? Oh, it's also worth noting that in a normal distribution, guys, in a normal distribution, which I will be talking to you about later, is that Q1 and Q3 will always be the same distance from here to the mean. So that's pretty much it. Or the median, because we're talking about normal distributions here. Now let's move on to average deviation. Now, average deviation is actually a cousin to standard deviation. But the reason why average deviation is not that used is because it permits the deletion of algebraic signs, rendering it a useless measure for the purposes of any further operations. Now, what do you mean the deletion of algebraic signs? Because in AD, guys, in average deviation, these bars, yeah, these bars that you see here actually mean that you have to use the absolute value. When you say absolute value, take this for example, -9, and you want to plus it with 4. Ang answer kay 8765. 5, negative 5. You know why? Because this is the bigger number. Now, what do you mean by absolute value? When you say absolute value, the signs doesn't exist. If -9 siya, you literally say, nah, let's not talk about this. And it's that. So mahimo na siya 5 lang. Gets ba? Absolute value. You don't care what sign it is, right? So that's what the bars mean here. That's what the bars mean here. This small x actually permits this small x actually means ano? It actually means the raw score minus the mean. Since diba, I said before that the big X, this big X over here, this big X means the raw score, while the X bar means the mean, the average. So you already know what the sigma means. It's the summation, right? Now let's move on to how do we actually solve this thing. Well, we're actually presented here a distribution of scores, and I want you guys to answer with me, no? So let's start over here. Let's presume that the average deviation is equal to the summation of the absolute value. Yes, yes, the summation of the absolute value of x minus x bar over n, which is the number of scores. Now, this is how you solve it, guys. AD. All you have to do is find the average between these, right? Now, how do you do it? Well, all you have to do is just add them all. Let me just get my calculator real quick. I'm so sorry, guys. Let me just. Aha. All right. So we get 85 plus 100 plus 90 plus 95 plus 80. Divided by how much numbers? 1, 2, 3, 4, 5. So 5. So our mean is actually 90, right? 90. Now, we want to minus this from the scores. Now you get this, no? You follow this formula. So you get the raw score. So 85 minus 90, 100 minus 90, 90 minus 90, 95 minus 90, and 80 minus 90. So this actually means 5, right? This means 10. This means 0. This means 5, and this means 10. Next, once we already solve this part, we now try to summation it, or sum it, sorry. Sum it rather. So let's do it, shall we? So 10 plus 5 plus 10 plus 5 is, hold on, let me get my calculator. 10 plus 5 plus 10 plus 5. It's equal to 30. So this is the score. So we can actually put 30 now here over n, which is 5 points, which equals to 6. And here, it actually shows that it's the AD of 6. Gets ba, guys? Hopefully I'm not going too fast. You can just replay the video if any case malisdan mo. Sorry. Now let's talk about standard deviation, guys. So this is where most of the people know where they're coming from, no? Because like we've already heard of this. The reason why standard deviation is good, guys, is actually instead of using the absolute value of each deviation score that we just did over here, right? Like like na minus should siya ba? Yeah, na minus should siya. Like hold on, yeah. Like diba 85 minus 90 kay -5 man siya supposedly, but we're using absolute value, so therefore the signs doesn't exist. So yeah, instead of using the absolute value of each deviation score, we use the square of each score. I'm gonna emphasize the square of each score here, because once you square the score, it automatically becomes positive despite it being negative. Like for example, you get -9, you square it, it becomes positive 81 because you times it by himself. And we know the sign means if you get minus, yeah, you get the idea, guys. Come on, it's PEMDAS. It's common PEMDAS, guys. PEMDAS, it's common math, pala. Yeah. So, yeah. So, oh yeah, because all oh yeah, sorry. Because all the deviation scores are squared, we know that our calculations would be complete until we go back and obtain the square root of whatever value we reach. What do you mean by square root? Because ano man gyud ba, like when you don't square root it, it's actually the variance, right? It's the variance. Well, but when you square root it, it becomes a standard deviation. Please remember that, guys. Like if you don't square, if you square it lang, it's variance. But if you square root after the squared, it becomes standard deviation, and that's pretty much it. So this is actually the hold on. Yeah, this is actually the most used or the most known na formula, no? Now, all you have to do is like sample standard deviation is equal to the summation of x minus x bar, which is the raw score and the mean, over n, which is the sample size. That's pretty much it. Squared. See? Notice the squared here, guys. Notice the squared here. Diba before kay wala tayo squared? Now we do. Thank you very much. And yeah, that's pretty much it. So actually, guys, kung sample siya bitaw, I don't know if like magawa siya, but like just in case na lang, no. If you use n minus 1 if we're using a sample. But we use n if we use n if we're talking about population size. Yes. But kung sample size, it's actually denoted by this sign, no? Just s. If it's s, kay we use n minus 1. You know why? Because it refers as an unbiased estimate to the population value. But if it's a population, then we use n lang. Gets ba? Alright. Now let me just erase all this. Okay. So to conclude it all, no, standard deviation is a very useful measure of variation because each individual score's distance from the mean of the distribution is factored into its computation. So it literally like speaks value to its so-called standard deviation, no? Because each individual score's distance from the mean is actually factored into its computation. So no one gets left behind. That's basically the whole premise of it, no? Next, we have skewness, guys. So what is skewness? Skewness is the nature and extent to which symmetry is absent. When you say skewed, think of something like biskag straight siya, kay hiwi siya. That's basically skewed. Hiwi siya, hiwi. Now, I've actually already discussed this last video, but I'm going to discuss it again. So when you say positive skew, few of the scores is actually high end. So ingani ayang noun, guys. Ingani ayang noun. Like this. While ang negative skew is when relatively few scores is at the low end of distribution. So ingani siya is the negative. This is positive. This is positive. This is negative. Gian, how do you know if it's positive or negative? Well, that's very simple, Jimmy. First, take a look at your toes. Take a look at your feet. If ang right foot, diba your big toe is in the left side, right? Yeah, your big toe is in the left side, and like it becomes like this, right? When you look at your right foot, this is your right foot. Your right foot means a positive skew, while your left foot, your big toe is in the opposite direction into the right. This is your left foot. Your left foot is actually negative. Because sa right foot kay diba pataas siya. Same man pod sa positive skew, pataas siya pa left. Same pod sa negative. It rises to the left. It also rises to the left. All you have to remember, if it's right, then it's positive. If it's not, then it's negative. Just look at your toes, guys. That's what Ma'am Darth says. So with that out of the way, now let's just continue. So we have a positive skew. We have a negative skew. This. We know that mean, median, mode, right? Diripod, mean, median, mode. The mode is always at the peak. right? The mode is always at the peak. The mode is always at the peak. The median is always in the middle, and the mean is always here. Gets? Okay. Now, again, positive skew, few of the scores fall at the high end. So gamay ang nasa high end of the score. If this were in a scatter plot, this would be the x, this would be the y. So the higher the score is, yeah, few of the people score high. While here, kay, a lot of people actually score high as well. Score high, sorry. Now, when it's in a positive distribution, sorry, yeah, hold on. Sorry guys, it's very tiring, man, gid ba? Let's take, for example, a positive distribution. Most of the scores are at the low end of the scoring range. Therefore, we have to make the test much more easier. You know why? Because a lot of people failed here. Balik kanang diri kay 95, kani kay 80, kani kay 100. A lot of people barely made the cut, guys. So therefore, you have to make the test more easier. The opposite is true for negative skew, where most of the scores fall at the high end of the score range. So therefore, you have to make the test harder para ma-normalize iyang distribution. Gets ba? So actually, guys, many people think that skewness is a negative thing. No, it's not always a negative thing. Think of Marines think of the Marine soldiers, guys. Like, if we want soldiers that are fit, we want soldiers that are exceptional. So therefore, skewness in this context is important, right? Because we want like a strong, like an exceptionally strong guy instead of the average guy. We want a high average guy for our soldier, right? So nga na siya. Skewness isn't always bad. Same put as error. Now, let's talk about kurtosis, guys. Kurtosis is actually the steepness of distribution in its center. Again, the steepness of distribution in its center. So as you can see here, in this graph, we actually have three kurtosis. We have platykurtic, leptokurtic, and mesokurtic. Mesokurtic is usually denoted as a normal distribution over here in this blue line, This dotted blue line is actually a platykurtic, while this one is a leptokurtic. How do you remember its names and what it does? Kung mesokurtic, meso means middle, so therefore it's the standard deviation. This is what we're trying to achieve. Ang platykurtic, mo siyang plateau, right? Mo siyang plateau, so therefore platykurtic. Ang leptokurtic kay, I don't know, basta taas lang ang leptokurtic, guys. Ayun. Next, let's talk about the normal curve. Actually, guys, the normal curve was made a concept by so many people. But Carl Pearson is credited with being the first to refer to the curve as the normal curve because it was actually called a Laplace Gaussian curve before. So he called it a normal curve in an effort to be diplomatic to all the people who helped develop it. So yeah, it's actually also called Gaussian in some cases. So theoretically, the normal curve is a bell-shaped, smooth, mathematically defined curve that is highest at its center. Therefore, ingani siya. It's highest at its center, right? With no skewness and ranges from negative infinity to positive infinity. Theoretically, by the way, the mean, the median, and the mode are same exact values. So if you were to put it here, this is the mean. This can also be the median. It can also be the mode. So we actually have the area under the normal curve. Actually, guys, you are advised to memorize these percentages, in each standard deviation, because we know that this is the standard deviation right now. These are like each standard deviations. So 1 standard deviation, 2 standard deviations, 3 standard deviations. So please memorize 34.13, 13.59, 2.14, and 0.13. Actually, wala ni show ang 2.13, but that's okay, no? All right. So I'm just gonna skip this part, guys, because I believe you guys know how to read and have reading comprehension, hopefully. Because sometimes I don't, guys, being honest. So let's talk about standard scores. Now, standard score is a raw score that has been converted from one scale to another scale. Well, again, why can't we use raw scores in our psychological report when they're literally saying like how many items have been correct. Well, Jimmy, ano man yun ang standard score man yun? It's called standard for a reason. It's standardized. Because when you say a raw score, it's literally just taken from the test. But once you have a standard score, this score can be interchanged to a lot of standard scores, and it's open for interpretation, and it can be open for statistical manipulation, right? That's a lot of words. I'm so sorry. So raw scores may be converted to a standard score because standard scores are more easily interpretable than raw scores, as what I've said. With a standard score, the position of a test taker's performance relative to other test takers is readily apparent. Because if you were to take the raw scores lang, then it's raw, right? But when you say standard score, you can actually compare it directly or relatively to other test takers who's taking that same test. Now we actually have a lot of standard scores. Let's first talk about the Z-score. So the Z-score has a mean of 0 and a standard deviation of 1. What does that mean? When you were to put it in a normal curve, guys, ingani siya. If you were to put it in a normal curve just like this, and ingani siya, here kay 0, here kay 1, here kay 2, dire kay -1, -2. Why? Because the standard deviation is 1. So 1 standard deviation, 2 standard deviation, minus 1 standard deviation, and minus 2 standard deviation. Gets ba? So that's what Z-score is. And this is the formula of Z-score. See, it's actually the same setup as the standard deviation because X, raw score minus mean over standard deviation instead of the number of values. So yeah, pretty much it, guys, no? Hago lang siya ang Z-score, guys, because you really have to find a standard deviation. So if wala pa siya gihatang standard deviation, good luck na lang. I advise you to memorize na lang the formula, no? Next, let's move on to T-scores. Now, instead of 0 and 1 as a standard deviation, as a mean and standard deviation respectively, the T-scores have a mean of 50 and an SD of 10. What does that mean if you were to put it in a graph? So instead of 0, 1, 2, let's remove this, shall we? It becomes 50, 60, 70, 40, 30. Why? Because we have a standard deviation of 10. So all you have to do is plus 10, 60. 60 plus 10, 70. Ayun lang, guys. It's so simple. That's T-scores. And T-scores are actually called 50 plus or minus 10 scale. While ang Z-score is actually called 0 plus or minus 1 scale. Literally based off their mean and standard deviation. So McCall actually named the T-score in honor of his professor E.L. Thorndike, the guy with the Thorndike's box. You know that guy, the guy with the cat. But if you don't, then I advise you to also search up him because he's actually important in the field of psychology. But anyways, never mind of all of that. So one advantage in using T-scores is that none of the scores is negative. Because sa ano man yun ba, sa Z-scores, kaya it's open to negativeness. Negativeness is open to negativity. Tama ba? Kay 0, minus 1. Sa T-scores kay, it's really so kanang free. It's so free. So yeah. So the reason why mas preferable siya is because Z-scores are again, pwede open siya for negativity, which makes further computation cumbersome in some instances, right? We also have a stanine, guys. A stanine actually has a mean of 5 and an SD of 2. That's pretty much it. Ang GRE, guys, or also known as the A score, has a mean of 500 and a standard deviation of 100. So when you think of kanang taas bitaw siya, like hala dako lagi ning mean og standard deviation, then matik, it's the graduation record examination score or the A score. We also have deviation IQ, guys. This is actually very because ang deviation IQ, we have a mean of 100 and a standard deviation of 15. So the mean again diri kay 100. And then 100 plus 15 kay 115. So if your IQ is 100, you're actually, congratulations, you're one of the average people. But if it's more than 100, holy crap, then you're crazy, bro. So ayun. We also have linear transformation. This is a standard score obtained. Sorry, let me just read it all. Standard scores converted from raw scores may involve either linear or non-linear transformation. A standard score obtained by a linear transformation is one that retains a direct numerical relationship to the original raw score. So when you change it, bitaw, guys, like for example, from Z-score to, let's say from T-score to A-score, the transformation of that is linear. You know why? Because dili bitaw siya discontinuous. Like it's Like kung example, sorry sorry. Let's say 50 and 60. Dili kay 100, 115. So they're basically like on the same page, right? The opposite is true for non-linear transformation, which is required when the data under consideration are not normally distributed, yet comparisons with normal distributions needs to be made. So that's pretty much it, guys. Can we have a break for 5 minutes? I'm so sorry, guys. I'm gonna drink water. Be right back. Sorry. Hello, guys. I'm back. I'm back. All right. Okay, so let's move on to normalized standard scores. So many test developers hope that the target test they're working on will yield a normal distribution of scores. Yet even after very large samples have been tested, skewed distributions result. What should be done? Actually, guys, dili man jud nato mapigilan, guys. We can't really say na murag the scores that are yielded will always turn out to be a normal distribution, because it's not always the case. There's bound to be again error. So let's say kanang ingani imong distribution. What's this called? This is positive or negative? Take a look at your feet. This is negative because this looks like your left toe. So yeah. So what happens if it's not normalized, or kanang there's a lot of skewed distributions that result from that? We can actually try to normalize that distribution, which involves stretching the skewed curve into the shape of a normal curve and creating a corresponding scale of standard scores, which is also known as a normalized standardized score scale. So you're literally manipulating the data to form this into this. But you need to have a certain type of normalized standard score scale to really, manipulate this into turning it into a normal curve. So here is actually a graphic presentation, guys. Again, from what I've told you, these are the standard deviations. This is the mean. These are the percentiles. Now percentiles, these are the percentages that are taking all of the normal curve area. For z-scores, we start with a mean of 0, followed by 1 standard deviation, 2 standard deviation, 3 standard deviation. So 1 standard deviation na siya. For t-scores, start with 50 as the mean, and we have 10 as the standard deviation because 50 plus 10 is 60. For a-scores, or the graduate or the GRE, we start with the 500 as a mean, and we have 100 as standard score because 500 plus 100 is 600. For IQ scores, we start with the mean with 100, and we have a standard deviation of 15 because 100 plus 15 is equal to 115. Pretty much it, and so on and so forth. Now, for test developers intent on creating tests that yield normally distributed measurements, fine-tune the test according to difficulty or other. It is generally preferable to fine-tune the test according to difficulty or other relevant variables so that the resulting distribution will approximate the normal curve. That usually is a better bet than attempting to normalize skewed distributions. So, actually, guys, my mind is not working anymore. I'm so sorry. Yeah. Basta ka mo nalay ana. So let's talk about concept of correlation. Guys, we already know naman that correlation is the degree and direction of correspondence between two things. It doesn't mean this variable A causes variable B. It's not kanang if variable A then variable B. It's not like that. Correlation is if variable A increases, variable B also increases. So there's like a respondence, there's like a correspondence, there's actually a relationship between these two, and that's correlation. You're finding the correlationship of both variables. So again, is the degree and direction of correspondence between two things. What do you mean by degree and direction? Degree, its magnitude, like how strong the relationship is, and direction, asa siya padulong, is it positive or negative correlation, which I'll get into in a while. So the correlation of coefficient is actually there is actually it's actually a sign. Sorry, it's actually can be a number anywhere at all between -1 and +1. When you say +1, if your correlation coefficient is +1, this is a perfect correlation, a perfect positive correlation. While ang R -1, this is a perfect negative correlation. Does that mean, Gian, does negative correlation mean na it's bad thing? No, it's not. Negative correlation just means that variable A increases while the variable B decreases. While ang positive correlation is when variable A increases and variable B increases. That's pretty much it. Okay, let's take for example kanime. So since ang range nato sa correlation coefficient is -1 and +1, how strong is this correlation? This is very strong actually. This is very strong because it's near this part. It's almost 1. It's actually almost 1. Kani guys, is this a strong or a weak correlation? This is actually a very strong negative correlation, guys, because this is close to -1. How about this? Is it a strong or a weak correlation? This is a weak correlation. Pretty much it. Yan lang, guys. And by the way, if correlation is 0, then absolutely no correlation exists. But to be fair, it's actually very hard as well to get a 0 correlation because there's bound to be a correlation between two variables. It can either be through chance, it can be through error, or it can be through noise. So it's as impossible as it is to gain a perfect correlation, it's also quite impossible to get a 0 correlation. So let's move on to Pearson R and Spearman. Now, these two are actually the most used or the most frequently used na correlation, right? We have the Pearson and we have the Spearman. Now, we use Spearman when the variables is linear and continuous. What does that mean? Linear, again, as what I've said, pwede lang siya interchange without any nuisance. Like, example, 50, 60, kani kay 100, 115. This is linear. This is linear. Continuous in the sense na, again, from noir, right? Continuous siya, kay it goes on and on and on, as what I said sa last video. So Pearson R takes into account the relative position of each task score measurement with respect to the mean of the distribution. So yeah, you use Pearson R when your variables is linear and continuous. That's pretty much it. Linear and continuous kay Pearson R. The same goes for the opposite for Spearman row, is because you use Spearman row when the sample size is small, fewer than 30 pairs of measurements, and when both sets of measurements are in ordinal form, or in this case, discontinuous, guys. You also use Spearman if it has curvilinearity. What do you mean by curvilinearity? Curvilinearity is like this. Let's take for example a scatter plot. Right, like a scatter plot. Hold on, a scatter plot. Usually when you say positive correlation, kaingani siya. A lot of data points going high. Same goes for the negative correlation, but it goes down. It goes down like this. Huh? No. Sorry. It goes down like this pala. Like this. But curvilinearity is like this, guys. Like pa-curved siya. So when your data is curved or has curvilinearity, you can actually use the Spearman technique. Yeah. So ayun, guys. So an outlier, you guys know what it is, an extremely atypical point. So in some cases, outliers are simply the result of administering a test to a very small sample, or outliers can sometimes help identify testers who don't understand the instructions, not able to follow the instructions, or or a positional and did not follow the instructions. That's pretty much it. We also have meta-analysis, guys. When you say meta-analysis, it's if you say correlation, it's a single study. But if you're gonna use a lot of studies to find or tell us about the matter under study, combined sila, that's called meta-analysis. It's a family of techniques used to statistically combine information across studies to produce single estimates of the data under study. Now, for single studies, we have correlation. But for meta-analysis, we have effect size, which is typically expressed as a correlation coefficient. So, kung meta-analysis siya, guys, and you're looking for a correlation for that, you most likely you call it effect size. That's pretty much it, guys. Let me just go back here. Actually, I forgot to, I know, to discuss it. We also have coefficient of determination, guys. Now, this is actually not a Spearman or a Pearson type of correlation. This is actually a correlation for how much variance is shared by the x and y variables. Like, how far are they in terms of distance, in terms of like how unrelated they are. Basta both variables siya, guys. It's both variables involved. So, that's pretty much it, guys, for part 2 of chapter 4. Medyo kapoy siya, but fighting. Thank you.